Hi guys, welcome to another video of me teaching mathematics. I am Abhinav. I've done my bachelor's and master's in electrical engineering from IIT Kharagpur. So this is the second episode of the playlist Definite Integral as a Limit of a Sum. In the first episode we have discussed the basics of the concept and we have derived some formulas and we have solved the follow-up question based on the concept. In this episode we are going to solve this particular question which appeared on JEE Advanced 2022 in its second paper of mathematics. This is a single correct answer question. So you are given a function f of n and you have to evaluate the limit when n tends to infinity. Alright, so let us go ahead and solve this question. But before we go through the solution, I would strongly recommend you to pause this video at this moment and give this question a try. So with that, let us dive in. So this is the question that we have and this is the formula that we have derived in the first episode. Alright, you can always go back to the playlist and watch the first episode if you don't know how this is derived. Alright, so now let us go ahead. So somehow we have to express this f of n in sigma format. Alright, we have to find out some pattern in the given function. Alright, now if you observe the numerator carefully, so the first term is 16, second term is 32, third term is 48. Alright, so these are just the multiples of 16, and if you observe the denominator, the first term is 4n, 8n, 12n. So these are the multiples of 4, and if you observe this last term, it is 7n square. Alright, so 7n square. Since in every term this 3n square is a constant term, alright, so this can be written as this 7n square, it can be written as 4n square plus 3n square. So initially we have 4n, 8n, 12n, and finally we have gone to 4n square. So from this, so the first term is 4 into 1 into n, and the second term is 4 into 2 into n, this 8n, and the third term is 4 into 3 into n, and this last term is 4 into n into n. Alright, so these are n terms. Alright, these are n terms. Alright, now what is the general term for the numerator? I mean for the denominator. The general term for the denominator is 4 into r into n plus 3n square. If you put r is equal to 1, you'll get the first term, it will be 4n plus 3n square. Alright, if you put r is equal to 2, you'll get 8n plus 3n square, which is your second term. If you put r is equal to 3, it will be 12n plus 3n square. Alright, so the general term for the denominator is 4rn plus 3n square. Now let us check the numerator. So in the numerator, if you observe carefully, so minus 3n square is common in all the terms. Alright, so let us do one thing. So this is the last term, 25n minus 7n square. So since minus 3n square is common in all the terms, so let us write up minus 3n square first. So minus 3n square. Alright, now this is 16 and this is 32 and this is 48. So that is like 16r. Alright, so if you put r is equal to 1, you'll get 16, r is equal to 2, you'll get 32, r is equal to 3, you'll get 48. So it will be 16r. Now let us focus on the middle term. Here you have 5n, here you have n. So first term is 5n. Alright, second term is n. So this n can be written as 5n minus 4n. Third term is minus 3n. So here we have minus 3n. Alright, so this minus 3n can be written as minus 3n. This is 5n minus 4 into 2 into n. So this is 5n, this is 8n. 5n minus 8n is minus 3n. Alright, so what is the general term? So it will be 5n minus 4 times r minus 1 times n. You put r is equal to 1, you will get 5n. You put r is equal to 2, you will get 5n minus 4n, alright, which is n. Put r is equal to 3, you will get 5n minus 8n, which is minus 3n. So the general term is 5n minus this is 4rn plus 4n. So this is 9n minus 4rn. So here we'll have 9n minus 4rn. So this is the general term for the numerator. Now we have this general term for the denominator and this general term for the numerator for these particular terms. Alright, so now f of n can be written as n plus sigma r runs from 1 to n 16r plus 9n minus 4rn minus 3n square for the numerator, and denominator is this thing 4rn plus 3n square. Alright, we'll erase this. Now if you observe, let us simplify this further. So this will be n plus sigma r runs from 1 to n 16r plus 9n upon 4rn plus 3n square. Alright, I have separated this term. Okay, now this will be simply minus 4rn plus 3n square by 4rn plus 3n square. So this everything is under sigma. I have separated these two terms and these terms and written it here. All right, so now this portion is simply 1. All right, so we'll just replace this with 1. All right, now this is n plus sigma r runs from 1 to n 16r plus 9n upon 4rn plus 3n square minus sigma r is equal to 1 to n 1. So what is this particular quantity? So 1 is getting repeated n times. So this is simply n. So this n and this n gets cancelled. Alright. So now your f of n is simply this particular summation. Now let us do one thing. Let us divide the numerator with n and multiply the numerator with n. Alright. So now we have r is equal to 1 to n. So we are multiplying the numerator with n, and when we divide the numerator with n, we'll get 16r by n plus 9. And let us divide the denominator with n square and multiply with n square. So this will be 4rn upon n square plus 3. So here n and n gets cancelled. So it will be simply n. So why did we do this? Dividing the numerator with n and multiplying it with n, and dividing the denominator with n square and multiplying it with n square, because here we have in the formula, if you check, we have f of r by n. So we need terms in the form of r upon n. So to generate such terms, we have done this particular manipulation. Alright. So now this is simply r is equals to 1 to n 16r by n plus 9 upon 4r by n plus 3. This is 1 upon n into 1 upon n. So here the variable is r. N is not the variable here. So variable is r. Alright. So this n is independent of the sigma, so we can bring this n out of sigma and we can write the n here. Alright, now we have to find out limit n tends to infinity f of n. So that will be limit n tends to infinity 1 upon n sigma r is equal to 1 to n 16r by n plus 9 by 4r by n plus 3. Alright, now if you compare this formula, so you have limit n tends to infinity, limit n tends to infinity, 1 upon n, 1 upon n, sigma r runs from 1 to n, 1 to n, and here you have f of r upon n. So your f of x will be 16x plus 9 by 4x plus 9, and when you put x is equal to r upon n, you will get this particular thing. Alright, so your f of x is 16x plus 9 by f of x plus 9. So to evaluate this limit, you just have to evaluate this particular integral 0 to 1 fx dx. So that will be, so limit n tends to infinite f of n is equals to integral 0 to 1 fx dx. Fx is 16x plus 9 by 4x plus, this is 3 dx. Alright, integral 0 to 1 4 times 4x plus 3 minus 3. Alright, so this is 16x, and here you have 4 3 is 12, 12 minus 3 is your 9. Alright, so this whole thing divided by 4x plus 3 dx. Alright, now this will be integral 0 to 1. So in the first term, this and this gets cancelled, so it will be simply 4. Alright, 4 dx minus integral 0 to 1 3 upon 4x plus 3 dx. So what is the integration of 4? It will be simply 4x minus 3. So integration of 1 by 4x plus 3 is ln 4x plus 3 by 4. So this is the integral. So we have to apply limits for this 0 to 1. Okay, let us put x is equals to 1 first. So we will get 4 minus 3 by 4 ln 7 minus, let's put x equal to 0, we'll get 0 minus 3 by 4 ln 3. Alright, so this will be 4 minus 3 by 4 ln 7 plus 3 by 4 ln 3. Alright, this can be written as 4 minus 3 by 4 ln 7 minus ln 3. What is ln 7 minus ln 3? It is simply ln 7 upon 3, and this is your answer. So this is the answer that you'll find in the options. So this is the correct answer. So this is just the second episode of solving questions on this concept. So you'll have more episodes coming up. Stay tuned, and if you like this video, give it a like, share it with your friends, and subscribe the channel for more such content. Thank you.